So the next presenter is Solomon Assefa. He's Vice President of IBM Research Africa and Vice President of Climate and Impact Science. And I first met Solomon at the ICTP in Trieste, where I think I first met Bill. So I met two with our panel. So Solomon is going to talk about scientific discovery, advancing scientific discovery for global sustainable development. So Solomon, nice to see you, and please take the floor.
Thank you, Joe, and very nice to see you. And thank you for the invitation. So let me just start by making a little bit of an introduction about IBM Research, because we're talking about a global community. IBM Research is also one of those institutions that represents a global community. We have about 3,000 researchers across the world. You can look at the map at many locations, and we've been around for over 75 years. And of course, a lot of accomplishments, and we've been, powerhouse in terms of, driving the IT revolutions for such a long time, but also including in the physical sciences, for example, the scanning tunneling microscope and so forth. So significant work, a very global community, and really driving, the frontier of science and technology. So without, dwelling on the past and the past accomplishments, what I would like to tell you is what we've been doing in the last decade, as well as what's coming next. And I'll just briefly explain three technologies that we're driving at the moment. The first one is AI. I think everyone here knows about the power of AI and how it's really becoming embedded in many of the things that we're utilizing and leveraging at the moment. But there's still more that's coming. For example, we all hear a lot about deep learning and machine learning and neural networks, but there's also, the frontiers such as neurosymbolic AI, which combines neural techniques, that's statistical representations, but also with logic and symbolic representations of knowledge and problems, right? So we're driving the frontier of that. And of course, there's also a lot of new things that are coming out when it comes to AI hardware as well. How do you, do inference and so training, and do you separate that? What kind of new architectures would be required for the future? And that's something that we're driving. And of course, AI for business, right? How do you embed AI in workflows, including discovery workflows? So there's quite a lot that we're doing at the moment. The second one is nanotechnology. And just to give a perspective, semiconductors have been really embedded, whether it's landing the man on the moon, or a man on the moon, or recent advances that we're seeing when it comes to space exploration, or in the last 2 years, all these advanced supercomputers being unleashed to help exploration of new vaccines and biotechnology, as well as even in our devices, including our mobile phones, right? And we have been really at the forefront of that. For example, just last year, we actually came up with a 2 nanometer technology, which is really at the cutting edge of transistor technologies, right? So again, this is something that will continue to drive, leveraging our global presence and global community of researchers. And then, of course, that is about classical computing. But for the first time, I think in our history, really, we're seeing the emergence of quantum computing. And that's kind of making things extremely exciting, especially looking at problems that have not been solvable up to now, right? And when it comes to quantum computing, we are really working a lot and innovating a lot, all the way from at the chip level, a lot of innovation in terms of at the qubit level itself, and then of course coming to the packaging, then putting it into the system, which you see to the right, and more than that, also making sure that these quantum systems are accessible to the world through the cloud, right? And that means that we had to innovate also in terms of the programming of these quantum machines, making sure that they're also accessible not only to just physicists and research scientists and engineers, but also to students and anyone who actually wants to make sure that they are part of this new emerging computing platform that's coming to the world, right? So this just gives you a flavor of some of the frontier technologies that we are advancing at IBM Research. And what's interesting at this point in time is actually these technologies are converging, right? We have bits. I talked about nanotechnology and semiconductors. We have neurons. I talked about new types of AI hardware. And then I talked about qubits, which is about quantum computing. And these are really coming together. And what we think is going to happen is that these technologies are going to actually really transform the scientific method. They're going to really supercharge it and, enable scientists to do discovery at a much faster rate, which is, again, which is important at this point in time, right? I mean, the last 2 years, once again, showed us that science has to be at the frontier. When you look at the pandemic, research scientists needed to come together, needed to use some of the cutting edge technologies to make significant advances based on advances that have been made in the last 30, 40 years in, for example, the mRNA platform, right? But beyond that, there are some pressing global problems that will leverage this type of acceleration of the scientific method. And one is, of course, it has been mentioned earlier, it's climate change and sustainability. So let me go a little bit deeper into that topic. I think many people following this know a lot about climate change, and many probably already looked into the past 2 reports from the Intergovernmental Panel on Climate Change. And there's, I think, 4 key points that come out from that report, right? One is that climate change is here, right? We see it in extreme heat waves, long droughts, frequent tropical cyclones, and melting of ice caps and so forth. And that's causing a lot of destruction, about $150 billion in cost because of damages. And of course, over 100 million people facing hunger, right? So that's one fact that's here. The second fact is that it is, human activity has a lot to do with it, right? If you go all the way back to 1880s and compare the trend now, there's a 1.1 degree Celsius, rise in global average temperature as well, right? So human activity, our industrial revolutions are at the heart of what we're witnessing now. And then the third one is, of course, a lot of actions need to be taken, both on the mitigation side as well as the adaptation side. The mitigation side is, of course, we need to reduce greenhouse gas emissions, and we need to remove greenhouse gases from the atmosphere. And on the adaptation side, it's about, we've got to be prepared, we need to manage risks, and then, of course, we need to also enable resiliency and recovery. And, there's a lot that's happening to accelerate this actions when it comes to mitigation and adaptation. And I think many people know there's a lot of investor pressure, for example, people being removed from their board of directors. And also there's a lot of consumer pressures, consumers pushing companies to be transparent. And of course, a lot of landscape shift that has happened in the last year. We have seen it in the US, in China, and across Europe as well. So there's a lot of desire to accelerate these actions. But the fourth and I think important point for me is, given this big problem that we need to find a solution by 2030 and 2050, how do we do it? There is no silver bullet, but technology is going to be at the center of it. And technology and innovation is really going to be at the center of it. And we have seen a lot happening in this space, right? People coming together to accelerate discovery, working together, collaborating, and also, a lot of technology hubs being created to advance technology. I won't go through a lot of this. It's just kind of an analysis of, a lot of the activities that we're seeing when it comes to innovation. But let me go a little bit deeper into 2 areas and connect it to this, emerging technologies that I mentioned, and how those emerging technologies are actually creating a platform for global collaboration, and through that collaboration to accelerate, the development of solutions. So materials discovery, specifically when it comes to carbon capture, is a very important problem. So, for example, if we specifically focus on carbon dioxide, it's over 70% of the global greenhouse gas emissions, and a lot of it actually comes from power generation, from power plants and so forth. Unfortunately, it's less than 1% or 0.01% that's being captured at the moment because of the cost of direct air capture, as well as capture at this power plant, point source capture, right? So there is this need for creating new materials, new processes, so that we can do it much cheaper and at a much bigger scale. And there's actually tens of thousands of scientists working on it, and hundreds of thousands of papers being published on it, a lot of money being invested on it by many companies. But it's a very, very difficult space, right? And that's because materials discovery is a multidimensional space and a very, very complex space that requires optimization. As because you have physical processes to consider, the material space, and then of course, even if you discover the materials, you have to think about what happens to those materials in the application space. So a very, very complex optimization problem, millions of configurations. And that's where we think there has to be a change in terms of our approach and how we do it. And that's where we believe AI itself is going to be very important. The first part is, as I mentioned, there's hundreds of thousands of papers being published and a lot of knowledge that's being generated, right? And that is very difficult for humans to keep track of. However, you can use AI to do deep search, which means to actually generate a knowledge graph, organize that knowledge, and make it queryable, right? So that's the first part of it, where AI becomes very, very important. The second part is then, based on that knowledge graph, it is actually possible to use AI to identify the gaps in that knowledge space and plug the gaps, plus generate new materials. That's where generative models come into play. And then the third one is, of course, when you have those candidates materials, what's possible to do is then go and say, instead of our usual simulation approaches, leverage AI to kind of enhance the workflows and, determine the right types of simulations that will be required to verify which materials we should go and try out in the lab, right? Then, of course, the fourth step is once you have identified those candidate materials, you can go into the lab, but the lab would be the lab of the future where it's fully automated. And I'll show you something on that a little bit later, right? So a lot of automation in the lab to enhance the knowledge of the human, right? And, we've been actually leveraging this concept, these four concepts, as I've mentioned, and, our researchers have already been identifying hundreds of different types of, monomers for polymer membranes. And of course, we go and then, do the molecular dynamic simulations. I'm just showing you some of the results of the candidate membranes here, for example. You look into permeability, selectivity, and so forth. And you see, for example, in this case, that's the one at the bottom. That seems to be the most promising candidate for us, right? From our exploration, going all the way from hundreds of thousands of, potential candidates, or, maybe selecting it down to, maybe hundreds, right? And the next phase is the automation that I mentioned. Then going and, automating the lab so that you can actually do this experiments over the cloud 24/7, right? All the way from the synthesis, all the way to the analysis and, understanding of the results and so forth. So, that kind of gives you a preview of what's coming, right? Materials are important, specifically for carbon capture, as I've mentioned. And there's, a way of accelerating our discovery in that space, but it's not just for carbon capture. We see this actually really being relevant for many of, the problems being addressed by the Sustainable Development Goals, right? For example, look at how we do fertilizers now and how we might do nitrogen fixation in the future, especially with the power of quantum computing, really understanding natural photosynthesis processes and nitrogen fixation processes could completely change how we are doing things now. The same with energy storage. I think, batteries were mentioned earlier. How do we get much safer, more sustainable materials? There's a lot of activities that are happening in there as well. And also, I mentioned semiconductors, right? Even in the semiconductor industry, there are a lot of, fluorinated kind of materials that need to be replaced, right? All the way starting from, photoresist, right? And that's a massive, massive industry. which needs, to be even more sustainable, right? And of course, drug discovery as well, especially when, climate change becomes more frequent. Obviously, it is going to have impact on human health, right? And perhaps in future pandemics, right? So there too, we believe that this type of, materials discovery is going to be playing a very, very big role. And, even though we're developing a lot of these technologies in-house in our global research labs, we also understand that, we're tackling global problems, right? So this global problems can only be solved through global collaboration. So our approach is really to make these tools accessible to, research scientists, engineers, students, and universities, research institutions across the world. And I'm just showing you a few of the examples from the past 2 years where we have significant collaboration. For example, with Cleveland Clinic on, accelerated discovery for, for drug discovery, right, for pharmaceuticals. And we have another collaboration with the UK Science and Technology Facilities Council, and that's more focused on sustainability, for example, right, and climate change. And then we have another collaboration with Quebec, Government of Quebec and Niemela Institute, and that is now focused a lot on climate change and sustainability and the semiconductor industry. And, with University of Illinois and its partners, our focus is, on things like, climate risk and impact, as well as discovery of new materials for carbon capture. So, we're casting a wide net and making these technologies accessible for use, but not only that, even for co-development with our partners based on the domain knowledge that we get, right? So now let me come to the second example, and that one would be on, climate risk and impact. Again, climate science is broad, but, given the fact that, some of the extreme events are happening, more frequently globally, it's important to think both at the, spatial dimension as well as temporal dimension, right? We got to think about, understanding extreme events that are happening, being able to forecast them, whether it's hours, weeks, decades out, but also making sure that we have the right tools in hand to understand those extreme events, not just in New York, but in Nairobi or Johannesburg or, Mumbai. So it's important to make sure that a lot of the work that's being done in climate science is actually not computationally intensive, but also that, these tools become more advanced, leverage AI, and become more accessible by the global community of researchers and engineers, right? And it's also important to go from understanding the science to understanding the risk and impact, right? So when we solve these problems, it's not just saying, hey, there will be an extreme event that's happening in Nairobi, for example, but to say, because, or Mombasa, for example, is to say, it's going to happen at this time frame. And when it happens, these are the regions, these are the supply chains that might be affected, right? So really, it's also a discovery problem that needs to be accelerated, for enterprises, for governments, for decision makers, and so forth. And we're doing quite a bit of work in this space as well. Again, just to give you an example of where AI becomes very powerful, right? AI could learn from some of the high resolution simulations from climate global models. And then you can actually use that learning to reconstruct some areas where it's unresolved, but, is important, right? So there's quite a lot of work that's happening in combining those physics-based models with AI technologies so that we can have, much better resolution, both temporal and spatial. Another area where AI is becoming also very useful is, from climate simulations, for example, or understanding and recognizing important features which might be easy to miss, especially if the data that comes out from this, simulations and observations is too much, you can actually train AI models or deep learning models, which then can do some of these identifications, for example, tropical cyclones, in a more automated way so that they will be able to flag those to the research scientists, right? So there's quite a bit of work that's happening in this space as well. And then the third one is also, which I mentioned, a lot of the simulations are, especially if they're physics-based, they're very computationally intensive. They take quite a lot of time, right? It is possible to use and infuse some of this AI techniques so that we can go from simulations that might take 4 hours to 8 hours to just 5 seconds, right? And that makes these technologies, this type of, approaches make these technologies more accessible globally so that, we could create research communities that can collaborate and work together using the latest technologies, right? And one more example here would be AI for extreme weather generation. And this is more about, generating what if, scenarios, right? There's a lot of, again, physics-based simulations that happen and so forth. But if we use, AI, we could come up with this what if climate scenarios. And, if we can project that out and play that what if scenario, whether it's like, 5 days out or, 5 months out and so forth, then there's an opportunity for governments to react, right? Private sector to come together, work together, and understand what might be the impact on supply chains or railroad networks and flights and and so forth. So this type of what if simulations are becoming more and more important and becoming more and more mature. In fact, we have put all of these technologies together and brought it out to the wider community. We call it an IBM Environmental Intelligence Suite, and we launched it last year. It was a big drive by IBM, not only to join the Climate Pledge and a few other institutions and making our commitments also on our goals for 2030. We also came out with this technology because there was a demand by many of the enterprise clients that we have, as well as many of the governments that we work with, that there is a need to bring together these technologies, make it accessible for them and make it more consumable for them as well. So as I've mentioned, our push is not just, in creating the technologies. We're taking a very global approach in terms of making sure that these technologies are accessible and they're solving, global problems. One good example, for example, is the relationship that we have established with NIH and, University of Witwatersrand in Johannesburg in South Africa, and many other institutions and universities actually, to come up with NIH programs that look at the intersection of climate change and health, looking at longitudinal data and understanding the impact and ensuring that while that's being done, these collaborations and these partnerships are actually being leveraged also for skill development, of training of interns, postdocs, and bringing together professors from across the African continent. And we are at the heart of it. As I've mentioned before, we have 2 research labs on the African continent, and we believe that our mission is not just to advance these frontier technologies, but also figure out how do we build a community of discovery that can actually come around these technologies and leverage them to have, to make discoveries, to accelerate these discoveries, right? For example, understanding these discoveries from a longitudinal study might, end up taking 10 years. But if we use some of the approaches that I just mentioned, we would be able to do it in a year or 2, which could have, significant impact in terms of future interventions, right? But it's also, clear for us that it's not just, our role is not just making these technologies accessible so that people can come and use it. We have to participate in skills development, in training, especially for some of these latest technologies such as artificial intelligence and quantum. And we've been very active about that. And this is an example of some of the initiatives that we've taken and invested in across Africa. And you can see we brought together our research scientists, some of the top in the world from the global labs. And we put together an AI seminar series. And it was quite interesting to see that there was such a demand for it, right? So over 2,000 participants, and this is across 38 countries. And beyond the participation, we still continue to see that there's growth in the replace of the lectures, right? Over 65,000 replaced already. And this is quite exciting to see because, like I mentioned, we do need some of this, significant research centers playing a role in technology development and providing the required training and creating such a vibrant community that can actually leverage these technologies. And in the African context, why I find this very interesting is the demographics, right? So it's a very young demographics poised to explode in the coming 10 years, and a lot of talent that comes out of the continent leveraging these newest tools and creating innovations at a network of innovation labs. All of a sudden makes it exciting when you think about how they can contribute towards solving some of the grand challenges and global problems that I mentioned. And another example is, of course, quantum. We call it Quantum Challenge Africa. And there what we do is we have strategic partnership, as I've mentioned, with Wits University, but through that partnership, we're able to reach to 16 universities across the African continent in 10 different countries. And all of a sudden, that creates a big network effect. And we are able to reach students and professors and make them participate in our quantum challenges, where they come together with our quantum experts from research perspective, domain experts perspective, as well as the technology perspective, engineering perspective. And they're able to actually think about potential use cases, right? Some of the use cases, for example, that were actually explored during this quantum session include: how do we leverage quantum chemistry for HIV drug design, right? How do we leverage quantum systems for speed up and finance and optimization? And how do we leverage quantum to optimize crop yield, right? And as you can see, these are actually touching the sustainable development goals, and students across the African continent are leveraging the latest tools to actually create innovation as well as scientific advances. And by the way, some of these problems are already leading to some significant scientific breakthroughs that are appearing in prominent and high impact journals. So it's quite an exciting time to see such activity coming out of the global south. And I mean, this just captures some of the concepts that I've been talking about, right? The latest technologies, the way they're being developed, whether it's AI, whether it's quantum, they're being developed as a platform that's accessible globally, right? The system has changed, how we approach these technologies, how we connect to them, the pricing model and so forth, it's completely changing, right? It's changed over the last 10 years. And this just shows you around the world, through our partners, through Quantum Network, that we have extended the different partnerships and some of the engagement mechanisms that I've mentioned, such as Quantum Challenge, how in the last few years, the IBM quantum systems have actually become a platform for participation, for collaboration, and for scientific breakthrough. I don't have the numbers off the top of my head, but so many publications that are coming out of this platform, right? Tackling, again, many topics related to sustainable development goals. So many partnerships, so many, student exchanges happening, so many collaboration happening, and that is really becoming quite exciting. So let me just conclude my talk by putting up this, this quote here, because I think it's very relevant. It's from one of the leaders that I really admire, Nelson Mandela. And it says that if you want the cooperation of humans around you, you must make them feel they're important, and you do that by being genuine and humble. I think we've established that these technologies are coming, the convergence is happening, they're becoming platforms for collaboration, and there's a lot of demographic change that's happening. And if you put that in context, and if you look at the innovations, the skills that are coming from all over the world, I think it's also important to think about how do we cooperate, right? How do we become humble, genuine when approaching these global problems that actually make us interconnected? It's not a problem that will be just solved in Europe or the US or in Brazil. These are problems that are actually going to require all of us to collaborate. And I think that will require a little bit of a change in approach, which has been addressed in some of the previous talks. So with that, I think I'll conclude.
Thank you very much, Solomon. Let's thank Solomon. And what a wonderful conclusion, actually. That's very important. So this is Bo Hammer, you remember from ICTP, and he's the guy that was responsible for me meeting you, and he's got a question.
Hey, Solomon, good to see you. Thanks for your great talk.
Hi, Bo.
So I'm curious, IBM is obviously doing amazing things in quantum computing and materials and, applying these in just the most remarkable ways. But with regards to climate change and the carbon impact of these new technologies, what, if any, sort of research is going on to sort of minimize the carbon footprint of these new computing technologies?
Yep, very, very good question, Bo. And I didn't mention it here, but we actually have a research program that we call Sustainable Computing. And we're looking at it from different levels. The first thing that you want to do is actually be able to understand, right, the carbon footprint of the systems itself. And, you got to be able to account for the carbon footprint itself, right? So that's the first one, making sure that you have the tools to really understand them. The second one is then how do you do the optimization so that you can do reduction? In our case, for example, there's a lot of hardware optimizations that are happening, packaging optimization that are happening, how you put the system together that's happening. And also from the data perspective, for example, right? Given that there's so much deluge of data that's coming, what do you put on some technologies that are like, for example, tape, right? Versus actually storing it in hard drive, right? In memory and so forth. So there's a lot of innovation that's coming from that perspective as well. And really also optimization of, cloud workflows. That also, there's a lot that's happening in that space as well. So I'll just leave it at that, but there's, there's a lot that's happening in that space.
One more. Oh, okay. Another question? Yeah, please use the mic.
Hello, thank you for your talk. I was just wondering, what is like the ratio of the projects at IBM that are focused on developing the tools and building the network versus the projects which are directly targeted at combating climate change and things like that?
So the ratio between, could you repeat it for me?
So, for example, it sounded like, IBM is doing a lot of work just promoting quantum computing, for example, and promoting AI and educating people about those tools in general. And I was just wondering how many projects are there which are directly targeting this specific.
No, it's, without going into the details, for example, I can tell you for last year, I was in charge of putting together hundreds of people from across IBM to develop the environmental intelligence suite that I mentioned, right? And from IBM, within IBM Research also now, we have hundreds of researchers fully focused on what I called accelerated discovery. Now, when we say accelerated discovery, we're talking about people working on healthcare and life sciences, people working on climate and sustainability, people working on sustainability of computing and nanotechnology. So we have significant effort that's dedicated into really advancing these topics themselves, not necessarily just the computing infrastructure and the other tools that we develop.
Thank you.
Okay,
And if I may add, we're not doing it. The change, the pivot that we've made is we're doing it in partnership because, yes, we're very good at the technology. Yes, we do have some domain knowledge, but the problems are so big that the only way to make progress in the coming decade and sustainable development goals is by really creating these partnership networks.
Okay, thanks. I think we're running now down to the end. I just wanted to yes or no question. So you mentioned that when we think about quantum, the next quantum revolution, and all the things that are coming up and the technological advances, et cetera, you talked about. Can we be confident that we'll bring the rest of the world, not just in the United States and Europe, where there's quantum initiatives, et cetera, but the rest of the world, the scientists, bring them along on this, because it is an international endeavor, of course, science?
Yes. Yeah, I'm very confident because we already have a win. And I will reference South Africa. We worked on it for 3 years with our strategic partners such as Wits University and CSIR. And we're actually able to develop a national working group that actually worked with government, which led to investment specifically targeting quantum computing and quantum science. So I think, and now that is having a ripple impact across the continent. So I'm actually confident that with this approach, with this type of partnership, definitely will bring along, others. And others have a lot to add, a lot of value that they bring, by the way. Right. Like, as I've mentioned, if you look at the African continent, look at the demographics, there's a lot of innovation, bright minds coming out and doing scientific breakthroughs. So it's mutually beneficial across the world. And I think somebody else mentioned that as well. I think Brito mentioned it earlier.
Right. Yeah, I think you said it right. It's a very mutually beneficial relationship to bring all sorts of visions. Okay, you have a quick question? Okay, please.
Okay, I'll try to keep it quick. Could you just speak briefly on how much of a role political willpower will play moving forward versus technological advancement? I think a lot of the technology is already developed, for example, in carbon capture or with sustainable energy production. Could you maybe speak to maybe your just personal feelings on the role that we have as scientists or not?
I mean, look, I'm a technologist, not a politician, so I'm biased about technology. But if based on my life experience, I would say that, policymakers and politicians are laggards for the most part. And again, you look at demographics change, you look at the amount of science and technologies that's being developed. I think the technologists and the scientists have a real power to change things and, move very fast. And hopefully we hope that politicians and policymakers will follow in terms of, not stifling those innovations. But I'm very optimistic about technology having significant role in solving these problems.
Okay. Well, with that, Solomon, thank you very much for that talk. It's really another wow talk. Let's thank Solomon again.
Thank you.